So once you've got your Sphero connected to your SpheroTurf Research app, at this point you may want to calibrate the direction to see which direction Sphero is going to be rolling. So you'll find the blue dot and make sure you understand it is rolling in this direction because the blue dot will actually be behind the direction it wants to roll. So you've got it calibrated. Now you may ask yourself, well, what does all this mean? What is x velocity? What is y velocity? Here's a brief explanation. If we're rolling in the forward direction, that's going to be our y velocity at that point. And then any side-to-side movement is going to be in the x, and any up and down movement is going to be in the z. And so what you're going to have is you've got velocity, so you've got the movement in a forward direction. You got its really, the simplest way to think of it is speed, since we do have directionality with it. And then we have the x, this as the ball wobbles, if it moves at all. And then we have the z in the up and down. But like I said, we have the velocity, we also have an acceleration. So with acceleration, what happens is as the ball begins to move forward, if you have a smoother surface, the ball begins to accelerate, so you'll see positive numbers as you're moving forward. But if you have a very smooth surface, the ball actually, at a given power, will need to slow itself down. So what's going to happen is the acceleration will actually move back, will actually become negative because the ball is trying to maintain a given speed at the given setting that you've set it at as far as the speed percentage is concerned. So you can think of that is, in many ways, you can look at the acceleration as far as the positive, negative acceleration. If you have more of a positive acceleration, then the ball was constantly having to work to keep itself up to a given speed. If you have a negative acceleration, then the ball is actually trying to slow it down, so you actually have a faster surface. So for the X, or the side-to-side movement, really that's just telling you more the wobble or the perturbation that's actually going on with the ball. Is if it's running into grain or it's running along bumps or things like that, it actually can begin to move. And harder surfaces as well will cause greater movement in the X, because what happens with a green is even though we see it as setting on a very flat surface, it's actually being held in, very gently along a very supple, soft green. It actually will create less X movement. And the same thing with Z movement as well. It'll create less Z movement on more supple, more softer surfaces. So that's some of the basics of that. And we also have the gyroscopic movement. And the gyroscopic movement is a little more complex. And the one thing we do understand right now as far as the pitch, and pitch is going to be related to speed in the fact that as in similar to the Y acceleration, the ball is going to pitch forward. Its accelerometer is going to pitch forward, and that's going to cause it to begin to fall or roll forward. If it begins to roll beyond its desired speed, it's going to have a negative pitch to begin to slow itself down. And you can see these in a lot of the per millisecond data measurements that are actually occurring. The per millisecond data measurements will show you if you have, it's going to pitch upward and begin to go up, and then it'll pitch back down and reach a steady state pitch in order to hold itself at a given speed. If you see that steady state pitch stay at a very positive numbers, that means it's having to work harder. If you see the steady state pitch actually drop to a negative, that means it's a smoother, faster surface, and it's having to pitch less in order to maintain that speed. And that's ways you compare between faster and slower surfaces. So that gives you a little bit as far as what's going on as far as the characteristics of the Sphero app, and I hope that helps some. There's also yaw and roll, and less is understood about those variables than is understood about the ones I just described to you.